Hi everyone. So in this video we will talk about the property right and the coase theorem. So here is a review of the last video. In the last video we talked about the deadweight loss. So from this graph, can you define which area is the deadweight loss? So remember our second method to find the deadweight loss. First, we need to find the market optimal level, which is the intersection of market private costs and which is the intersection of marginal private costs and the marginal private benefits. Is point E. Then we need to find the social optimal level, which is the intersection of marginal social costs and marginal private benefits, because there is only one marginal private benefit, marginal benefit line. So the social optimal level is 0. Then we need to connect the market optimal point and the market equilibrium quantity. We need to connect these 2 points and then extend this line to marginal social costs. Find point A until it reaches A. The triangle enclosed by those 3 points, A, the market equilibrium, and O, the social equilibrium, OAE. This area is the deadweight loss. So when you are answering a question in a quiz or homework assignment or exam, the second method would be much easier than the first one, I think. So the outline of this video, we will first talk about the property rights, then is the public and the difference between public and private. The third part would be focused on the coase theorem. So property rights. Property rights are a bundle of entitlements defining the owner's rights, privileges, and limitations for use of a resource. So without the property rights, the markets always have some problems, and those problems I will talk about in this video. So there are 3 different efficient property right structures. The first one is exclusivity. The second one is transferability. The third one is enforceability. So I think all of those, the definitions, like for example, all the benefits and costs should only accrue to the owner. Property rights should be able to transfer to others. Property rights should be secure from seizure or encroachment. I think the definition of those 3 structures should be very easy to understand. And there are 4 different types of property rights. The first one is the private property. For example, my phone and the cup is my private property. And the second one is the state property regions, owned and managed by government. For example, the state park, the national parks. Those are the state property regions. The third one is common property regions, that is, resources shared by a group instead of an individual, like our APEC dream, the Costco, the community club, the community park, the community forest. The last one is open access, which means no individual or group has legal rights to restrict the access. For example, the ocean fishery, that I cannot exclude you from enjoying the ocean fishery, right? So those are 4 types of property rights. And the third part of this video is the coase theorem. It is defined as when the transaction costs are negligible and the affected parties can freely negotiate with each other, and there are a small number of parties, an efficient allocation or an efficient production can be achieved, regardless of who is assigned the property right. So here we have several comments on the coase theorem. The first one is that the initial allocation of rights does not matter if there is no transaction costs. That is, if there is no cost of negotiation, there is no search cost, there is no legal expense, and if there are just a small number of parties involved in the negotiation, and those parties can easily be identified. Like the 2 examples I will cover in this video, we just have 2 parties involved in the negotiation, and there is no transaction costs. So from that 2 examples, we will find the initial allocation of rights does not matter, since the optimal allocation would be always same. So the second comment is that the distributional effect, the efficiency does not always mean equality, which we need to keep in mind when we talk about the efficiency. So sometimes it does not mean equality in some cases. And in the real world, often the transaction costs are not negligible, and many environmental pollutions affect a large number of people. So that means actually in the real world, the coase theorem does not work, because those 2 conditions. The first one is there is no transaction costs, but in the real world, the transaction costs cannot be are not negligible. And then the second condition is that there are a small number of parties, and those parties can easily be identified. But in the real world, the environmental pollution, the environmental problems like the air pollution, the water pollution, it affects a large number of peoples, and those peoples cannot be easily identified. So compared with tax or subsidy, the coase theorem is a market-based solution for externality. For example, the market would achieve the social optimal level, so we call the coase theorem is a market-based solution when there is pollution, such kind of externalities. So here is our first example to see the coase theorem. For example, there is a railway that runs trains through a farming area and caused fires in the crop fields. So we want to know what is optimal number of trains running per day, should be run per day. Does it depend on who has the right of this lands? Well, if the farmers and the railway company, if they can negotiate with each other and if there is no transaction costs, we would expect that the final optimal level of trains per day would be exactly the same, regardless who has the right of these lands, right? So the yellow table is the cost of running trains, which is very easy to understand. I think the table is pretty readable. The first column represents the private costs. The second column represents the crop damage. And the third column is the social costs, which is the sum of private costs and the crop damage. So, for example, when the firm runs 1 train per day, the private cost is $100, the crop damage is $200, then the total is $300, right? Here is a reference for this example. If you want to know more details, I think the link can give you a better explanation. Then suppose the revenue from running a train is $350. So how many runs are private optimal? So when I ask the private optimal, I'm asking this question from railways perspective. From railways perspective, they only care about their private cost and their private benefit. They don't really care about the pollution, the crop damages they produced, because that's not their assets, right? So if we want to answer this question, how many runs are private optimal? From the firm's perspective, it wants to maximize its profit, which is the difference between the revenue and the private costs. So the second column, the revenue column, lists the revenue from running different number of trains per day, and the private cost column is exactly the same as this private cost column is the private costs of different number of trains per day, and the profit is just the difference between the revenue and the private costs. So as we search below this column, or within this column below profit, we can see running 4 trains per day, the profit is maximized. 700 is the largest number among those numbers, right? So that means the maximized profit is achieved running 4 trains. This level we call the private optimal, keep in mind. So that's my first question. How many runs are private optimal? 4 trains. My second question is that how many runs are socially optimal? For example, if the farmers they have the right of those land, the railroad needs to pay the damage cost. So in this case, the railroad, their cost is the sum of private costs and damage costs, which is this column is also exactly the same as the social cost. The revenue is still the revenue, does not change. Again, we need to find the largest number below the profit column, which is 100. And the corresponding number of trains per day is 2 trains. So from the social optimal level, the maximized profit is achieved with 2 trains per day. Remember, the social optimal level, in the social optimal level, the maximized profit is achieved with 2 trains per day, which is different from the private view, because the private optimal implies that the maximized profit is achieved when there are 4 trains per day. So I have a third question. How many runs are socially optimal when farmers need to pay the damage costs? So this question implies that the railway company, they have the right of those land. So farmers, they need to pay the damage cost. Suppose the revenue from a train run is $350, which is exactly same as last page. And suppose farmers would be willing to pay the railroad $1,200 not to run any trains, and deduct $200 from this payment for every train run. Then, can you answer how many runs are socially optimal when farmers pay this payment? So, because the railroad company, they can receive the farmers' payment, they can also receive the revenue from train operation. Then their total revenue would be a sum of the train operation and payments of farmers. If the number of trains per day is 0, if they decide to not run train, then their revenue from train operation is 0. Their private cost is also 0. However, they can receive the payment from farmers, $1,200. Then the profit of railroad is $1,200, and so on. So in this case, the railway company, they only need to subtract the private costs of the railroad, since they don't need to take care of the pollution. The farmers, they pay the pollution. So in this case, where the profit is maximized is this area, is this area enclosed by this rectangle. When they run 2 trains per day, then their profit is maximized, which is at $1,300. So it does not matter who pays the damage costs, right? If the railway needs to pay the damage costs, the optimal level of the number of trains per day is 2. If the farmers, they pay the damage costs, then the optimal level is still 2. So there's no difference, right? Here is just an illustration of the cost theorem. The same level of production or allocation of resources, and in this case, is the number of train runs per day, is achieved whether the railroad company pays for the damage costs. All the victims, the farmers, they pay for the damage costs. It doesn't matter since the optimal level would be exactly the same. It doesn't matter who pays for the damage cost. It doesn't matter who has the right of those damaged land. So this is our first example. And in this page, I will describe another way to decide the optimal level. Remember, in those two tables, we decided the optimal level is to find the maximized profit, right? And another way to do that is to find the condition where the marginal cost is equal to marginal benefit. I think you should be very familiar with this condition, marginal cost equal to marginal benefit. But how about if this condition does not exist? For example, in this table, I cannot find anywhere that the marginal revenue is equal to marginal costs, like 350, 300, 350, 400, 350, 500. They cannot be equal to each other at any level, right? So here are two extra information I can provide to you. If at the n runs per day, if the marginal revenue is greater than the marginal cost, then the total profit is higher at n plus 1 runs than it is n runs. And at n runs per day, if the marginal revenue is less than the marginal cost, then the total profit is higher at n minus 1 runs than it is at n runs. Is it easy to understand? For example, from the private optimal level, from the private optimal's perspective, if the railway decides to run 3 trains per day, then the marginal revenue would be 350, the marginal costs would be 300. So what does those two numbers mean? The marginal revenue means the extra amount I can get for running one more train, and the marginal cost means the extra amount I have to pay for one more train I run. So the extra amount the firm has to pay is $350, and the extra amount the firm receives is $350, and the extra amount the firm pays is $300. Then the difference is positive, is $50. Then the firm would have incentive to run one more train because it can get extra $50, right? So when we say this, when a firm runs 4 trains per day, then the marginal revenue is 350. The marginal private cost is $400. Is it the optimal level to run? Yes, because at this level, the marginal revenue is less than the marginal costs. That means if the firm runs one more train, the firm needs to pay extra $50. So 4 units is the private optimal, and from the society's perspective, we need to compare the marginal revenue and the marginal social costs. For example, when the firm only runs 1 train per day, the marginal revenue is greater than marginal costs. So we know that there would be extra amount, there would be surplus if we run 1 more train, right? So when we run 2 trains per day, the marginal revenue is less than the marginal cost. Then we know we cannot get anything, but have to pay $50 for 1 more train, right? So we have no incentive to run 1 more train. That means number of 2 trains is optimal, is the social optimal level of running. So the private optimal level is 4 trains. Social optimal level is 2 trains. The results are exactly the same from another method, right? So this is the second method. Let's go to the second example of this video, and when I finish this example, the video is done. So let's go back to the demand and supply curve again. It's about the negative externality we talked about before. There is a steel industry. It produces steel, but also produces some pollution to the environment. It produces some waste into the river. Then the river is